Hey guys, it's Willman again here. So I originally was just going to make a big old video for our introduction to polynomials, but after I got done with the adding and subtracting portion, I realized that I already took up 10 minutes, and as a result, I kind of wanted to post a separate video for multiplying, just in case you wanted to look at it at a separate time or take a break in between, okay? So this video is only going to focus on multiplying polynomials. So without further ado, here we go. What I'm writing on the left, this is something that we have all seen throughout the school year in math class. This is a case where we need to do something called distributing to further along the problem. So remember, distributing basically means take the outside number times each one of the inside numbers and then tell me what you get. So 3 times 4x is 12x. 3 times negative 2 is a negative 6. So when we multiply polynomials together, it is going to be very, very similar to that idea of distributing. So that's something we can relate to. We're going to start by taking a binomial times a binomial. So we're going to take let's do 3x plus 2 times 3x minus 4. Okay, so if you ask any algebra teacher, Miss Keel, Mr. Withers, what their favorite English dictionary word is, it's got to be FOIL. You know why it's FOIL? Because FOIL stands for first, outer, inner, last. This is a cool process or idea that we can use to efficiently multiply two binomials together, okay? It works best when we have a binomial times a binomial. Otherwise, you have to modify it a little bit, okay? So how this works is first, let's multiply the two first numbers together. 3x times 3x, which gives us 9x, okay? 9x squared, excuse me. Next, you need to take the outer numbers together, multiply them. So 3x times negative 4, which is a negative 12x. Now we need to focus on the inner, the I, the 2 times the 3x, which is a positive 6x. And finally, a 2 times a negative 4, which is a negative 8. So, given this guy, some of you are probably thinking, hey, can we combine those two x's together? Absolutely, let's do it. So a negative 12x and a positive 6x combine to a negative 6x. And I still got that plus negative 8 at the end. And I still have that 9x squared in the front, okay? So this would be a good answer for what the two starting binomials multiply into, okay? So let's back up a little bit. All we did is we took the first number times each of the numbers over here and wrote down what we got. Then we took this number and multiplied it by each of the terms again on the right side, okay? You're just doing the distributive property in a sense 2 times and then combining your terms at the end, okay? So that was a binomial times a binomial. Let's do a binomial times a trinomial. Let's rev it up a little bit, okay? So let's do these. Example 2. Let's do 4a plus 2 times 6a squared minus a plus 2. Okay. You can kind of follow FOIL a little bit, but since we have this middle term here, we're going to have to adapt it a little bit. So instead of following FOIL directly, I'm just going to focus on 4a. I'm going to take 4a times everything on the right. So 4a times 6a squared is going to give me 24a cubed. A 4a times a, that's actually a negative 1a. So a 4a times a negative 4, excuse me, a 4a times a negative 1a is negative 4a squared. And then a 4a times 2 is a positive 8a, okay? Now, I'm going to focus on the second term in that binomial, a 2. I'm going to take 2 times everything on the right. So a 2 times 6a squared is going to be 12a squared. A 2 times a negative 1a is going to be a negative 2a. And finally, the back terms, 2 times 2 is going to give you a 4. Notice, you could write these all in a straight line next to each other, but by writing them on top of one another like I currently did, it's going to be very simple to combine these like terms. So if I take 4 plus whatever this is up here, that's a 0. 4 plus 0 is 4. 8a and a negative 2a is going to combine to a positive 6a. Negative 4a squared and a positive 12a squared is going to give us a positive 8a squared. And finally, 24a cubed and 0, it's going to give us that right there, okay? So this would be a good answer for what 4a plus 2 times 6a squared minus 1a plus 2 equals. This is our good answer, okay? Another way you know when you're done is that there's only one term with an a cubed, one term with this variable, one term with this variable, and one constant, okay? If you have 2 of some term with the same variable, you got to keep going, okay? All right, let's go to, I know what everyone's thinking, Mr. Willman, we did a binomial times a binomial. We did a binomial times a trinomial. Can we do a trinomial times a binomial? Absolutely. Let's try it. Let's do 2x squared plus 3x minus 4 times 5x minus 3. All right, so it's going to be kind of the same idea. Let's focus on one of these terms, the first one, 2x squared, and multiply it by everything on the right. So 2x squared times 5x is going to give us 10x cubed. 2x squared times negative 3 is negative 6x squared. There's nothing else on the right that I need to multiply by. It's all been taken into account, okay? So let's switch to the next term, that 3x. Let's take 3x times everything on the right. So 3x times 5x is going to be a 15x squared. Let's take a 3x times a negative 3, negative 9x, okay? Again, I took everything into account. I'm good there. Let's finally do a negative 4 times everything on the right. Negative 4 times 5x is negative 20x, and a negative 4 times negative 3 is plus 12, okay? All right, we're almost there. You need to combine all of the like terms together. So I see a positive 12 as a constant. That's the only one. Look how nicely set up this is. Now I got my negative 9x and negative 20x right next to each other. I got my negative 6x squared and a 15x squared. Nice. Then I just got my 10x cubed. That's a good looking answer. Good organization. This would be a good final answer for what our trinomial times our binomial equaled. 10x cubed plus 9x squared minus 29x plus 12. So, I know what some of you are thinking, Mr. Willman, I think I got it down, but I want to have a little more fun. can we please do a trinomial times a trinomial? I mean, I guess that can be our last one. Let's do a trinomial times a trinomial. Here we go. Let's do m squared minus 7m minus 6 times 7m squared minus 3m minus 7. All right, guys, you know the drill. M squared times everything on the right. Here we go. M squared times 7m squared is 7m cubed. M squared times negative 3m is negative 3m. Oops, that one's cubed. The first one is to the 4th. Teachers make mistakes, guys. All right, m squared times negative 7. So negative 7m squared, okay? I'm actually going to change those to positive negatives. Help me out. Okay, m squared is taken into account. Now let's move to the second term. Negative 7m times everything on the right. Negative 7m times 7m squared. Negative 49m cubed. Negative 7m times negative 3m. Positive 21m squared. Negative 7m times negative 7. Positive 49m. And you know what? Mr. Willman should have been organized and wrote these underneath like he did on the last problem. I'm going to write that underneath really quick. There we go. No harm done. All right, so now we need to take into account negative 6 times everything on the right. So to do the negative 6 times everything on the right, I'm going to first take negative 6 times 7m squared. So that's going to be an m squared, so I'll write it right here. Negative 42m squared. Now I'll do negative 6 times negative 3m, so positive 18m. And finally, negative 6 times negative 7 plus 42. The fun part's over. Now all we got to do is combine the like terms. So 42 is our constant. How many m's? Let's see, 67m. How many m squared? Let's see. 7, negative 7 and 21 should be 14. 14 and negative 42 should be a negative 28m squared. And then how many m cubes? Negative 3m cubed, negative 49m cubed, negative 52m cubed. And finally, 7m to the 4th. Okay? Wow. We started with these two trinomials being multiplied, and we ended up with this beast down here. So, there's an interesting thing going on here too. Notice, well, I guess maybe we'll bring that up next week. Okay. So, this was our little lesson on multiplying together polynomials. We did trinomials times trinomials, binomial times binomial, and combinations of all those in between. So I'm hoping that after you guys see these 4 examples, you kind of understand how multiplying really just breaks down the distributive property multiple times, okay? So if you wanted to pause the video at any point to try the problem on your own, feel free. Feel free to rewatch them. There's going to be some practice problems posted as well as an answer key, so give those a shot. See you later, guys. Thanks for watching.